Welcome to Team DataFam Tableau User Group meeting number 26. This tug works a little bit differently to others because we're focused on more the presenter than the audience. So we meet at a whole range of times to get the presenters when they're available, depends on where they are in the world. Obviously, all our meetings are held live like we are now. We record those meetings and put them on YouTube so people can look at them at any stage in the future. For the last few months, we've been doing a lot of TC25 presentations, and that's what we're doing tonight as well. But the tug is open to everybody to present. So if you've got something you want to present, please get in touch. My email is team.datafam@gmail.com. But today we have Robbin presenting Taming the Data Beast, Normalization Strategies in Tableau. So obviously talking about data, normalization, Tableau. It's Robbin's presentation, so I'll hand it over to him.
Thank you very much for the introduction, Chris, and thank you very much, everyone, for joining us this evening, morning, afternoon, depending on where you are. So let me just be sure, can you see a presentation slide showing up on the screen?
Yep, definitely.
Perfect. So as Chris said, Taming the Data Normalization Beast. Lorna and myself both gave this talk at TC. She's currently training our current group in training at the Information Lab and Data School, but we're both Data School coaches, so we live and breathe Tableau, Alteryx, and all other sorts of tools. And today I'm going to walk you through about what is data normalization. So I'm going to be talking about normalization within inside Tableau, not data model normalization, so not denormalization, normalization of data tables. So if that's what you're hoping for, stick around. It must be exciting anyway. I'm going to show you some examples in the wild, so use cases of what we're working towards, and then explain a couple of those techniques. First with z-scores, showing you a demo within Tableau, then moving on to parallel coordinates chart, which then lean into radar charts, again, demoing that in Tableau. And at the end, we're also going to talk a little bit about, well, what if I don't want to do all these calculations within Tableau Desktop? How do I do the data preparation in Tableau Prep when I just want to prepare my data beforehand and just drag things in? So what is data normalization and why do we need it, or why would I like you to use it? Is well to enhance some of the statistics, or enhance some of your visualizations with additional layers of statistics on top of them. So the process of transforming data from various sources into a consistent format, so you can compare things a little bit more like to like. That will then give you enhanced visualizations that allow for easier analysis, comparison between these values when you have a common scale rather than things that lay completely different scales. So by normalizing your data, you get that capability to compare things a little bit more like for like, and hopefully give you that enhanced analysis on top of that. And if not, it gives you great coloring on top of that too. So if I give you an example of two data sets, we've got the red, or sort of the light red one here on the left-hand side, that ranges between -50 and 200. There's a random amount of data points. There's a data point sitting in between. And then we've got our blue data set that sits between -5 and 150. Now, initially, we can see that the red data set is larger when it goes up to 200 and it goes to -50. But we can also tell that the spread between these data sets is slightly differently. And it's just a few data points. So what happens when we apply a type of normalization? Well, if we pick something like min and max normalization, we scale everything from the lowest value to the highest value to values of 1 and 0. So number 200 becomes number 1, -50 becomes 0. And for the blue data set, -5 becomes 0 and 150 becomes 1. And you can start to see, you can get a bit more of a say around the spread and see where some of these values sit in between. So the value 135 and in the blue data set and the value 170 in the red data set, actually 135 sits closer to 150 than 170 sits to 200, which seems reasonable, but you can see how the scale changes. Then we have another version. So rather than picking the lowest and the highest value and standardizing across that, we pick the mean, or the mean average. So we calculate z-scores. And what we do in here, we find the average of the data set and then see how all the other bubbles are ranging from that average. So we basically check in how many standard deviations the value is away from its own data set. And what we see is that the -5 of the blue data set that currently looks like is not that far away, is actually more of an outlier than the -50 is when it comes to the red one sitting all the way at the bottom. And then the last one is a statistic or a part of a normalization or standardization where we talk about percentile rank. Or percentile ranking you might see in sports a lot, where you want to rank yourself or teammates against each other and see, well, which person is number one, which person is number two, the 100th percentile being the highest rank, the 0th percentile being the lowest. And that gives us a great ranking method. So we see number 1, 2, 3, 4, the percentiles, but we kind of lose the complete connection to the original data set. So even though -5 and -50 are far apart from that range, they're both now at the bottom of the drawer, sitting at that 14th percentile. Now, these three techniques that I displayed here, they're just one of the few techniques. They all have different types of equations belonging to them. So min and max normalization has the observed value minus the minimum over the maximum minus the minimum. The z-scores that we talked about have the value itself minus the average over the standard deviation. And the percentile rank has to do with the position over the amount of observations that we have. All of which we have calculations and calculated functions for within Tableau and Tableau Prep to carry that out for us. But before I'm going to show you some of these examples, I'm going to talk through some use cases for them. So some charts that we've seen on Tableau Public or elsewhere that might lean towards these types of use cases, and we use those calculations for them. So a very simple example is one that I didn't speak about previously, or at least not in the bubble example, is we standardize things related to when somebody first enters the data set. So if we look at a player joining a different types of a sport, and we just want to see how many passing yards a certain player has, well, if somebody's been playing for 12 years or 12 seasons, that is already sort of an anomaly from that. And it's very difficult to then compare that against somebody that maybe started 10 years beyond that player and then wanting to trail their cumulative total of how many passing yards they have. So basically saying standardizing their seasons played to the first season they've ever played in, you can now basically easily track that different types of player across each other, even though they might have played in different eras. Now, looking at a z-score plot, and you might see some of these workout Wednesdays come by more recently as well. If you want to look at some of these percentile rankings, it allows us to compare things between groups. So on the left-hand side, we've got a normalized jitter plot where we compare BA, OBP, OPS, and LCLG against one another. And then on the right-hand side, we're looking at incidence rates, where we also compare different types of countries within different types of human development indexes. And we rank them using things like rank percentiles, or in this case, just normal rankings. Of course, on the left-hand side, you might recognize this is a radar chart. And in this particular example, on the right-hand side, you actually see the calculations that sit behind these radar charts. And we have different type of magic being performed within the scene of Harry Potter. And this is the Harry Potter and Deathly Hallows Part 2. And there are some metrics related to individuals in here. So Severus Snape, the courage, cunning, magic, temper, and wisdom. All of these could range from anywhere between 0 and 10 to 0 and 1,000 or 0 and 10,000. And by standardizing them between 0 and 1 and normalizing them, it then allows us to have a comparison between these metrics, which we can then plot on a radial axis to then get a radar chart. This is one of the examples we're actually going to build. So this is New Zealand Rugby League player statistics, where within teams, you obviously have different positions. Different positions do different things within games. And therefore, if I want to find out whether a person is better at, for say, tackling within a certain position than their teammates in the same position versus another position, and how are they tackling in there? Obviously, in a normal data set, you'll see people that are in positions that are due to score a lot, they're there to make the game, then of course they'll score a lot, but we kind of want to also compare that to say, well, from another position, how much are they scoring according to their peers in that position? And we have some z-scores in here as well as a percentile rank, but it will get quite messy. You need all of these charts next to each other in order to actually make sense out of them. So we're going to do that in a second. So narrowing it down a little bit around calculating our z-scores. How do we go about doing that, and what is it for? Well, the z-score is a statistical measure that describes how many standard deviation a data point is away from the average of a data set, and mean average. It gives you an understanding related to the relative position of that value. It allows you also then to find common patterns within different groups of data. And what are they typically used for? Well, maybe if you remember from school and maths, you actually calculated those so that you can use that lookup table to find T and P values. And most of the time we don't do that anymore unless we're doing some data science. But that's what they come from. But actually have a really good value for us when we start doing visualizations. So how to interpret the data that comes out of this? If a z-score is 0, it means you're exactly the mean. So you're the mean of your data set. If you then become positive, so you go above that 0, it means that you are above that mean. And if you go negative, you're below that mean. If you are anywhere on the range of between 1 and 3, you sort of sit in a positive side, 1, 2, 3 standard deviations away from that mean. Why would I then use it in particular in charts? Well, for instance, we can build control charts with them. We can build enhanced box plots. We can do scatter plot analysis, which we're going to do in a second. And we can give the user cues to basically say, well, which ones do we consider an outlier? Maybe which points do you need to keep an eye out for? If we look at a line chart on the middle or the bottom left, I would have probably guessed, looking by eye, I have maybe 2 outliers in here. But if I put an upper and lower band around it related to sort of the standard deviations away from the mean, we can give them a range to look at. And of course, because we're in Tableau, this can all be parameterized. I'm not going to build this particular example, but you can give the user cues to basically say, well, maybe we should investigate these in more detail because statistically they sit within this range. So this is the equation, just to recap that. The actual value minus the average value over the standard deviation of those values. So we are going to do that within Tableau. And I'm going to start with a relatively simple data set, I hope. And what we have in here is 2 histograms where we've grabbed 200 random people around the world and their heights. So it's picked from the average height for female and males all across the world. And you see in blue Lorna, who's my co-presenter, and myself, Robbin, here in orange. And yeah, unfortunately, I'm quite of an outlier in this situation, but I am Dutch, so it's a bit unfair to compare myself against the average of the world. But Lorna sits way more sort of in the middle in that bracket of 160. What if I want to do some sort of comparison with this me against Lorna? Am I more of an outlier than her? Well, what? Probably definitely are, but how do we translate this into something where we can utilize these z-scores? So I've turned the histogram into a scatter plot, or just a bubble chart. To be honest, we only have one axis. We have the sum of height, and we see Lorna's height, and we see my height. Now, how do I apply a z-score to this? Well, for the z-score, what we're after is we basically want to find the mean of every data set, and then I want to calculate what the standard deviation is, so I have an idea of how many standard deviations am I away from that. And we can do the same from Lorna. So I'm going to create a calculated field for that called z-score. I'll try to zoom in as much as I can. And we'll start with just the height on its own. So this is the value that we're after. I'm going to prefix that with a bracket. And we want to subtract the average of the data set in here. Well, because we already have the sum of height, I can't do an average of a sum of height. And therefore, we utilize the window function so we can use table calculations to aggregate an already aggregate. So we want to have the window average of the sum of height. And we divide that over the window standard deviation of the same value of that sum of height. And now when we have that calculation, you already see that these results are computed across the table across. So there's a table calculation present. And if I bring that in here, it just simply shows up null. So at the moment, it tries to get the average and standard deviation just for myself, for every single individual mark in here. So when we go into our table calculation, I'm going to make sure we compute it across the right metrics. So what we're after in here is we want the groups to be the sex of female and male, and everything else it needs to be calculated across. And what we then see over here are our z-scores. So Lorna sits about 0.7 standard deviations away from that mean, whereas I actually sit 3.5 standard deviations away from a normal distribution. I sit definitely in over that 99.5% outlier sort of sitting there at the end. Now, of course, if I want to compare myself to the average of, let's say, Dutch males, and I bring this in, I simply say, well, give me the sum of height. This is the average height of a male in the Netherlands, and this is the standard deviation. We can simply plot that, to see an even worse picture for Lorna, whereas I'm only 1 standard deviation away from the mean, which in my head sort of makes sense because I was definitely not the tallest of my friends group while growing up. And Lorna is the unfortunate -2 standard deviation versus Dutch males. But again, this is what z-scores are all about, and they're fairly easy to calculate as long as we know the equation. And we're going to play around with these table calculations to make sure we compute them across the correct groups. So bringing it onto an example where we look at the National Rugby League, the NRL, from 2017 to 2025, I've plotted 2 different metrics here on the screen. Even if you don't know anything about rugby, I mean, I love rugby, that's why I use it. There's the amount of tackles that people have made over all of these seasons and amount of meters that they have run. Now, this is a little bit unfair because people might have only just started playing this game, and maybe I want to exclude some of these players from the game that have only played X amount of games. But what is better if we just standardize these metrics, say, well, let's just look at the tackles made per game and meters run per minute. So that might be the first type of standardization we do before we then go ahead and say, let's apply z-scores to them. So just to show you that picture, if I want to look at the tackles made per game, we simply pick up the tackles and then we want to have that divided over the total games and the games played. And I'm pretty sure that's just a distinct count of the game ID in the data set. Yep, that is right. So with the tackles made per game, I'll put that against it. And you'll see how they start to become sort of a little bit more evenly spread rather than going anywhere between 0 and 3,500. It goes between 0 and 60. And there's a few players that just have very, very small anomalies. They played once and they made 60 tackles. That must have been an amazing game. And then we do the same for the meters run per minute. Of course, it can again be meters run per games played or tackles per minutes played, because not everybody plays the whole game. But just to show an example, this would be the meters run over the minutes played, which would be this one as a sum. See if I've done that correctly. And once we bring that in, we end up with the scatter plot here on the bottom left, where it already becomes easier to see that there are definitely some clusters within different types of positions people play in, which is identified by the colors in here. And we can then also say, well, let's say people should have at least played 10 games. We end up with this pretty neat scatter plot. So we do some comparison, but if I look at some people that sit here on the bottom right, they're hookers. Maybe they tackle more, but they run less, versus the fullback sitting here on the left. They run more, but they tackle less. Now, is this player Dylan better at tackling compared to their peers, so all the other fullbacks, or is the player Reed a better tackler versus the rest of their peers compared to their group? So we're trying to compare different types of positions to one another just to see if we can use that to our advantage. So when we have this scatter plot, we'll then move on to say, well, how do we then turn that into the z-scores? And we use the same equations that I've highlighted when we looked at the heights of people. So I'm going to create a new z-score for the tackles per game. And let's see if I've used this phrasing already. If I've used the same name, I don't think so. So we have got our tackles per game. That is our value or our metric that we want. And we want to subtract the window average of that tackles per game. And we want to divide that over the window standard deviation of that metric. Got that part in here. Again, it will be no. I'm just going to quickly copy this over and repeat the same process for the z-score for the meters run per min played. Just quickly replacing the metrics in here. See if that worked out. And remove those two. And we're going to make sure that we compute them across the correct path. So I already have their full names in here, so they need to be calculated across that. I already have a highlighter. So restarting every position, calculate the average and the standard deviation. I'm going to do the same thing for the calculation at the bottom. And we end up with the following scatter plot. Now, this looks like a mess to start with, but we're going to use some highlighting on how can we bring them together to then actually do that analysis. So in this particular dashboard, I've just put them together. And what I have in here, I have the games played. So let's reduce that again so we get fewer players into a view just to see if the people that at least played 10 of those games. And I can see a couple of people that I've highlighted in here where they sit accordingly. So here on the left-hand side, we have Dylan being the meters played per minute, or meters run per minute, and tackles per game. So you have 5 tackles per game, seems pretty low. But if I look that in the Z-score part, he actually sits very, very close on what the average is of what these fullbacks do. If I, for instance, check the other one here, James Tedesco, he actually sits far below. So if I'm after a fullback that needs to be doing quite a bit of tackling, because that's advantages for our game, probably pick out somebody else from this batch in here. What I can see, though, is that actually both of the Reed Maroney, the hookers sitting over here, their tackles per game are way above their peers that we can see over there, but they actually don't run that much compared to some of the others in there. So they both sit on the negative sign of the meters run per minute. So we could, for instance, pick up a different hooker if we want people that are more lean towards that meters run in a game, if that's what we're after. Okay, so this is one way to utilize these Z-scores, because I also talked about control charts and different types of parts. All of that will be available on Tableau Public as well. You can download this whole workbook. But just for the sake of this demo, I'm going to leave that one there. And if you've got any questions about it, of course, at the end, we'll be able to go over that. Another option of standardization is parallel coordinates chart and radar chart. So that all focuses around 0, 1, or min-max normalization. And why would you do that? Well, if you work with highly dimensional data, so you break down your measures across many, many different ways, you have loads of data points and lights going, and it's very hard to tell any patterns between them. So a scatter plot can look at things between 2 metrics. Parallel coordinates chart, you can follow those trends across as many of those metrics as you want. So it's that visualization technique that is used to display very multi-dimensional data. And any overlapping lines you can then easily track with sort of the charts that I'm going to display. Why would you use one? As we've just already said, handling highly dimensional data, detecting any patterns in relationship, and exploratory data analysis is usually the one that I lean towards when I start with a new data set that has so many dimensions in here and even some of these measurables. And I first want to do some exploration to see, well, are some of them even related? If one of them sort of goes up, does the other one go down? Can I see particular trends for different types of teams, different types of categories, so that I can then build out my future charts, and even sometimes put in that parallel coordinates chart into my final dashboards if that's so desired. To show you the equation for that again, it is the actual value minus the minimum value over the difference between the maximum and minimum within that group. So you can probably already guess this is going to be leaning towards those table calculations again, and the window ones in particular. So let's go ahead and do that within Tableau. So what we have in here is an example of some of this highly dimensional multi-measure data. So what we have in here is, if you're used to Tableau, this is Sample Superstore. So this is a pretty basic chart that you might have seen before. So we're looking at the subcategories and then their sales, profit ratio, and number of customers. And I can utilize color to highlight some of the lows and the highs in here. If I, for instance, look at copiers, though, yeah, I can see that they're pretty good at their profit ratio and the sales sort of sits in the middle and the number of customers are low, but it becomes hard to track that across the ones that sit in that middle layer. So how do I then turn that into a parallel coordinates chart so I know which one or which ranking or which part does that bookcases or copiers sort of sit in, so I can track it across? This is the baseline of what I would start with if I want to build a parallel coordinates chart. And we use measure name, measure values. But of course, the problem then becomes is that our sales range is so large versus then our profit range, and then the number of customers even being smaller. It becomes very, very hard to track any of those subcategories if I show them as a highlighter. So if I look at copies in here, I can just see it slopes down and it's actually number one in profit in this case, not profit ratio, and then number of customers here. So how do I apply that standardization? I'll do that for the sales first, and then hopefully I've got some pre-calculated calculations at the bottom so you don't have to see me write that again and again. So 0, 1 normalization for sales. Because of course I also have a technique so you don't have to write it one by one. It's going to be the value itself minus the window min of that sum of sales over the window min minus the window max. Window max minus the window min. I thought it correctly. I said the wrong thing. But hopefully this is going to work out if I just keep talking and keep working. Get that in here, one more bracket, and we end up with our equation that I was aiming for. Now, if we bring that into the measure name, measure values, I remove my sales, make sure that the compute is done across the subcategories. You can already see that all of the sales now sit somewhere here in the bottom, so anywhere between 0 and 1. So we can repeat these steps, so we can end up with an axis that is going to be identical for all of them. So I've got my normalized sales, I've got my normalized profit ratio, and I've got my normalized customers sitting on here. Just going to make sure I compute them across the subcategories, and you can see how the parallel coordinates chart is starting to appear. And I can look at those copiers again in this case, and we can see indeed our copier sits in terms of sales about 0.45. It goes back up, but actually the amount of customers that buy copiers are very, very low in here, meaning we sell them a lot, high profit ratio, but only a few customers buy that from us, and it allows us to track things. We can build calculations on top of it to also color it. So if I want to color these lines to make sure that they're computed correctly. Yep, they are. So I can highlight things when they have a high profit ratio, when they have a high customer sales, and when they have the high normal sales, just to see those patterns and track them across the parallel coordinates chart. I would say Sample Superstore is not necessarily a highly dimensional data set. It is pretty decent, but what if you have way more than this? What if I have 6 in this particular case, and I only picked 6 of the statistics that you can get from, let's say, the New Zealand Rugby League data set that we've got? This then becomes quite a lot of effort to build out all these individual calculations. So what we'll do instead is actually, well, let's just utilize the functionality of Tableau where we simply pivot our data. So we don't have to put measure name, measure values on. We already got a name and value as a column. So I've prepared a data set for that, and everything is now broken. So I'm going to go back into the data set to basically do that pivot. So I'm going to make sure I remember which of these metrics I want to pivot. But this is the data set that sits behind it. And I've got our meters run all the way down to our tackles made. And if you highlight those within your data model, you can right click on them and just say pivot. And what you end up with is with all your values sort of sitting here on the right hand side, is the name of the header is now within a column, and then the values sitting just next to it. So it makes your data quite long, but we can utilize this to then build the same chart without having to put in measure name, measure values. And now we only have one value. What does that allow us to do is, well, if I then replace my calculation of value with just saying, well, I refer to value in everything, we can then break up the view with the metric on the columns, and then we can calculate our 0 to 1 normalization way faster. So just replace those two. I'm gonna make sure that I set them up correctly. So I'm going to calculate them, restarting every metric. So across the team, restarting every metric. And now you end up with sort of a bump chart feeling, or well, it's still a parallel coordinates chart, where you can check on how some of these teams are doing across. So we have the Panthers being their number 1 and number 2, or the number 1s in all meters run, all runs, but then being low in line breaks, and they're low in missed tackle, which I guess is a good side there. They're pretty decent in the tackles made. But we can follow some of the others, the Eels and the Dragons, going across and see sort of how they're trailing across their peers. Now, this 0 to 1 normalization is all the basis for radar charts. As long as we have something that is now on a scale of 0 to 1, doesn't matter whether it was sales, profit, meters run, line breaks, these parts, we can then plot them on a radar chart. Before I jump into that, though, I want to briefly go over why we would then move from parallel coordinates chart to that circular format. To be honest, it's the only reason is because my stakeholders asked me to do it. It's common performance in metrics, especially in sports, right? In radar charts, in my opinion, if you have 2 teams laying on top of each other or 2 players, sure, it becomes very quickly for me to see where one excels over the other. But when you have 2, 3, 4, 5 radars on top of one another, I can't see anything anymore. And even the parallel coordinates chart itself will be easier to find them out. But people are not used to seeing the charts, hence, will they get what they need out of the parallel coordinates chart, or will they get what they need out of the radar chart? So let's build a radar chart on top of this calculation. In order to do so, I'm going to first build it just using standard features. So I'm not going to use any of the extensions that we now have available, which I would highly recommend just to save you some time and pain when it comes to these calculations. But what the calculations are, we basically need to find out how many metrics I'm going to have. So I'm using 5 or 6 of them, and they basically find out on a circle what is the angle in which I need to plot them. And then I'm going to use math to basically figure out what is the cosine of that particular angle and what is the sine of that particular angle versus the distance. And the distance is simply that 0 to 1 value that I always have. So I can nicely plot it on a circle. So distance in this case, in my calculation, is just referring to the normalized or standardized version. So you still have to standardize your data for these radar charts, otherwise they'll look quite funky. And in this case, we'll go ahead and build one of them. So I've got a couple of things already on my view. I'm going to make sure it's a polygon, and now I'm going to remember, or try to remember, where I'm going to put my X and where I'm going to put my Y, because I cannot ever remember where they have to go. This looks correct to me, but let's see how I go for that. So we got to compute all of these calculations in a certain way. So our normalized values have to be calculated just like we did before. So we're going to do them across the teams, restarting every metric. So every metric is scaled between 0 and 1. And then within the angle, we're going to do the other way around, because we want to plot them along a circle. So for the angle, we're going to say by metric, restarting every team. And then slowly and steady, some funky pictures start to show up. But we're going to make sure we do that for every single calculation in here. So the angle is going to be by metric, restarting every team. And then the normalized score is going to be by team, restarting every metric. And I'm just going to double check this angle in here too. The angle is going to be by metric, restarting every team. And now this is a radar chart, but because it's a little bit squished, it might already be a bit difficult to see. So if I do standard, sort of becomes a square. And if I then try to pick up the eels again, rather than having these points from left to right, they're simply plotted on the top. So offloads, they're very good at offloads. If I flip back at that in here, in the eels, they are #1 in offloads indeed. So you simply plot it in a circle going around. We have the center being that 0 and the outliers. You can find, Panthers, yes, they are the best in that metric. Tackles made, the Knights are the best. Here at the bottom, we've got our line breaks for the Storms. Now, if you don't want to do this and you want to have a little bit more say around the way it looks like, there's 2 extensions I'm going to showcase. One of them is to show me more radar. I'm going to allow that. I'm going to have to remember where to put things. These extensions are pretty brilliant. I'm going to put my metric onto the spokes. I'm going to put my team on my dimension. And my normalized value goes on the measure. So that's the Z part in here. We're going to make sure that we compute that correctly across the team, restarting every metric. And then just like that, you've got your same radar chart already labeled for you to use. Now this one has sort of curvy lines in here. We have another one from La Data Vis radar, which follows the similar metrics. We've got a little bit more say when you want to have straight lines or curvy lines sort of going across. So the metrics will go on the spokes here. We've got our team name that's going to go on the color. And then a normalized value is going to go on our values. There we go. So I can have a line style that is linear. And to be honest, I like this one quite a lot. You can have them cardinal, or you can have them cat mole rom. But you've got a lot of say over how thick these lines are, the fill opacity behind them. So you do have quite a lot to play with. And this is a free version, of course, but you can allow them, you can get them to work. They are pretty brilliant in what they're doing. They make life so much more easy for us to utilize and build the charts when we do need them. Okay, I whizzed through that demo, but what about preparing data within Tableau Prep? There might be a few reasons why you might want to do that. If you do not want to do any dynamic filtering, so if they're filtering within the visualization itself, so you don't want your normalization to be recalculated whenever you add years to them, whenever you add, remove some players from the visual, you want those numbers to remain the same, then pre-preparing your data set and just relating them onto your data model might actually be advantage. Because some of the calculations can start to become an impact on your performance. So most of the times I've used table calculations now, and they're not that bad if you don't have that many marks in. But some of the other ones, maybe you require LODs and you start to get a sort of grinding to a halt when the data set goes over the 100,000, 200,000, into the millions. And you can still refresh these statistics whenever you just schedule your prep flow. So I'm going to do a demo in prep showing you how you can calculate all of the three things we've just done. Actually, two things. I did z-scores, I did 0-1 normalization. I'm also going to show you rank percentile, actually one that we haven't done, which is also a table calculation that you can do within Tableau Desktop. And we just do that in one single step within prep. So as an example, I'm going to use sample superstores just because we're familiar with it. And let's imagine that our categories are going to be our subcategory. So what we'll do for this, I'm going to aggregate my data set because we want to compute all of those statistics over the subcategories. So I'm going to bring in my subcategory as my group by, and then I want to have my sum of sales. And I want to have my, what else did I want to do? Just do the sum of profit. And then I want to have the distinct count of customers. So basically know how many customers I have. What comes out of this is a table that is 17 rows, all of which has sales, profit, and customer ID sitting in here. And if I want to apply the standardization method, normalization methods I showcased before, it again makes it easier if we pivot our data, right? So we go from columns to rows, so we can do the calculation across sales, profit, and customer ID in one calculation, especially if we need to calculate things like the mins, the max, the mediums. It will take up a lot of time otherwise. I've made my window very big now. So what I will do is I will create a pivot step. And in this pivot step, I want to just group by my subcategories. Nope, I do not. I do want to group by my subcategories, but I definitely do not want to pivot them. So let's remove that. So I'm going to select all my metrics and push them in here. And just to briefly add a cleaning step and show you what the table looks like, right? We've just simply pivoted our data right now. If you pivot values and your pivot names across your subcategories. All right, so what I'm going to do from here is first show you that you can actually just create the percentile rank from here as we go. So we've got some pretty neat features available in Tableau Prep nowadays where we can do those types of calculation by simply creating a percentile rank from the get-go here. So I want to do it across my pivot value names, and then I want to calculate the percentile rank, restarting every pivot name basically. So across the subcategories, which subcategory ranks number 1, and which subcategory ranks number 2 within sales, etc. So we're going to create a calculated field called rank. And we've got a pretty neat drop down in here. So we don't want to group by the full table. We want to restart for every name so that sales, profit, and total customers is considered individually. And this is just the normal rank, right? Number 1 down to number 17. That comes out of this. But we can go to the drop down and say we want a percentile rank. And from our percentile rank, we want to make sure that we rank it ascending in this case. Ascending meaning that I'm 0th percentile if I have the lowest value, and I'm the 100th percentile when I'm the highest value. That sort of comes through that. And we save that. Let's just rename my calculation to be percentile rank. Now, that's a pretty cool feature. We don't have to use any further calculations for that. We simply create that with one calculated field. But for the other ones, we're going to need things like the min, the max, the average, the standard deviation. So we need a whole bunch of them from our pivot values. So if I want to do an aggregate step from here to create those, I'll put that down and I'll make sure that this cleaning step is ready for me to go on top there. I want to say I want to group by my pivot names. And then I want to say from my values, for instance, I want to have my average. Now, if you do that once, then that measure can no longer be selected here on the left-hand side. So I can only average, min, max one of those columns once. So beforehand, I actually have to duplicate these values as many times as I'm going to need them, so I can use them going ahead. So I'm going to create duplicates from that in here. Some other tools, you don't require that. So I'm just going to name them to the duplicates that I need. So I'll need the average, I need the standard deviation, I'm going to need the minimum, and I'm going to need the maximum. And when I have those calculated, of course, later on we can deselect them, we no longer need them. Here from the bottom, I can then, let's delete that one for a second, simply match up those names against what I was looking for. So this is going to become average. This will become my maximum, this will become my minimum, and this will become my standard deviation. There we go. So what we have coming out of here is simply one row for each of the pivot names. And again, if we had profit, sales, customer, we had 10 more of those, they would automatically create in here because we have the group by feature. You got your minimum, maximum, standard deviation, and average, which are all used in those normalization techniques that we've showed. So we simply have to join that back onto the data set, and then we can do row by row level calculations for this. So what I'll do is I'll join this onto the flow that comes there from the top. I am going to join that on the pivot names only. So we got 51 matches, 3 from there. So that looks all good. I'll add a clean step to that, and I am going to make sure that the min-max here on the right-hand side are the correct ones. I should have removed them from here, and I'm going to do that because otherwise I do not know which one I need to use. Make your life easier, remove all the fields you don't need beforehand. Right, we got our min-max and standard deviation. So the percentile rank still sits at the end, and I'll just briefly walk through the calculated fields for that. So the z-score, again, I can't zoom into prep. I'll just zoom in with zoom it. We grab our pivot name values, we subtract our average, and we divide that by the standard deviation. Now this time I do have to make sure to use those brackets. I'm going to click apply. And then our z-scores are added to the start of the table. I'll create the last one from the 0, 1 normalization as well. That's going to be our pivot values minus our minimum over the difference between our maximum minus the minimum. And following a very, very similar equations like we created in Tableau, but we don't have them to be dynamic. And after we done that, we can make sure that we remove all the fields we used to create this. And what you end up with is a table that simply already contains, let's do some sorting in here by the pivot names. The sales that already has the percentile rank, it has the original value, which is currently called pivot values, and we've got our z-score and normalization. So let me also remove the duplicate of that. So normalization between 0 and 1, z-scores standardize around 0. We see the pluses and minus. You see the percentile rank from 0 to 1 appearing over that as well. We can then unpivot this, but I'll leave you to figure that one out, just to stick within our time and just briefly recap what we've just looked at. So I've rushed through all of this, but some of the key takeaways that I'd sort of say, well, in z-score we can use to help and understand a relative position of a distribution and of a value within the distribution. It's very good to do group-to-group comparison and spotting some of those outliers. The 0-1 normalization is comparing and ranking of values on the same axis. So very good at visualizing highly dimensional data and bringing forward some trends and patterns. And why would you use prep? Well, the normalization of the data pre-devising can help you reduce sort of the complexity as well as the load times when you start building these types of calculations on larger and larger data sets. But it still keeps that baseline the same regardless of your filters. So with that, I would like to thank you very much for sticking with me during this presentation. And if you have any questions, of course, feel free to ask. I'll stop sharing my screen.
And I was on mute, so no one heard that. I was saying you stole my slide because my next slide was the Q&A slide as well. The chat was pretty quiet. I think it was like me, everyone was like amazed at the maths and following along with it, and it was just so easy to do radar charts and a few other things like that. The key's always the table calc syntax.
You'll become a master at using table calculations when you build this kind of stuff.
Definitely, for sure. There's no questions. That's okay. We'll continue on. There's all Robbin's contact details if you need to get in touch. And this will obviously be in the recording as well, but Tableau Public, LinkedIn, X or GitHub. So you've got some code up there as well. Still no one's going to ask any questions. That's okay. So I'll move on to the next section, which is Fast 5. So 5 quick questions, quick answers, I hope. It's all just personal preference. So if the questions get too hard, you can pass, but there's no right or wrong answer. It's just personal feelings on your side.
Sure.
So the first question is, what's the most misunderstood feature in Tableau, in your opinion?
Most misunderstood feature in Tableau, in my opinion. Ooh, I get so many questions all the time and misunderstood. And mine. So from my day to day, what people struggle with the most is the feature that you can write row level and aggregate level calculations. And then when you're in a calculate field and say, why can't I take the sum of sales and subtract profit from it? That kind of understanding takes like a long time for people to sort of wrap their head around. So I think that's one of the things, is that they make it so easy for us to write calculations that we kind of forget what we're asking from it all the time. And then some things it just can't do. And then I get the question, why doesn't this work?
Yep. And everyone's seen that error, right? And cannot mix aggregate and non-aggregate calculations. It just depends on if they actually know what the answer to that is as well.
Yep.
That's a good one. Question 2, what has your perspective on data, or how has your perspective on data changed since you started using Tableau?
The speed to results is so much faster than I thought it would be possible. So previously to using Tableau, I've been using it for 7 years now. I worked in academia for a long time, and every time when we had data, I was okay, well, this is going to take me about 2 days to get anything out of this and just sit there. And then you explore Tableau and you start dragging and dropping stuff in, and you saw how quickly you can pivot around stuff. I was like, no, I want to see it break down by this now and by that now. And rather than having to wait and readjust your charts, whether you used Excel or Python or R, it's like the speed to answers is so fast. So then my perspective in that is, if people say, oh, this is going to take me weeks, it's like, no, you can get some quick takeaways. If you want to make stuff look pretty, yeah, okay, that will take me weeks. If you have a big data problem to solve in the back end, yeah, okay, that will take a while. But if I just have data and getting to some answers, that can be very, very fast. So I don't let people use that as an excuse anymore. If they have time, that is.
Yeah, no, perfect, easy. Question number 3, what's the most creative or unconventional use of Tableau you've seen or built?
The one I got into most recently was Minesweeper. So one of my colleagues built that, and I've never understood that game. I used to play it on a computer, and might be young. I just randomly clicked, and somebody built Minesweeper in Tableau, and it's on Tableau Public. I think I can't remember the author's name, so I'm not going to even guess, even though it's my colleague. It just actually taught me how to play Minesweeper, and that was nice, because they had some information in here, and I was too annoyed that I couldn't beat my colleagues by not understanding it. So that's very unconventional use.
Yep, awesome. Yeah, there's been a few games in Tableau as well. It's crazy, crazy good, not crazy bad. Question number 4, would you rather click buttons or use keyboard shortcuts?
In Tableau, I actually click a lot. It's strange because in Ultrix, I only use shortcuts. So they're like, yeah, click buttons, definitely for Tableau. It makes it so easy.
Cool, that's easy. And the last question is, would you rather make maps or regular charts?
Maps.
Awesome.
If it's personal preference.
Yep, perfect. No, it's personal preference. That's all that is. So that's great. Thank you for that. So our next tug is in 2 days' time, even a day and a half's time. So again, everyone in Europe, sorry, you've got to get up with Saeed and be awake at 2:30-ish in the morning. But Marco's presenting basically a repeat of what he did at Visit Sydney, is talking about the art of storytelling in Tableau. So especially important for this audience here is all these recordings are put on YouTube. So I don't, as I said at the start, it doesn't matter whether these tugs are this time at night when you can attend, or in roughly in 12 hours time when you can't attend at all. Everything's on YouTube, and every online tug that sends recordings in is on YouTube as well. So you can get all those recordings at youtube.com/team.datafam. We've just passed 5,200 hours of watch time and 1,200 subscribers. So there's a lot of people on there. That's, as I said, it's the easiest place to learn more and attend more tugs, is just look at the recordings. There's also a Spotify and an Apple podcast. So whether you want to watch or listen, whatever, this recording will be up there very soon. Obviously, this is more of a watching recording to see how all those table calcs are built and added to the sheet and modified, and how it works and what the end result is as well. But you can always listen. There's a few people listening to the podcast you listen to it to say, okay, I've got to go back and watch that one, and then go back and watch that on YouTube as well. But as always, if you have any questions or need any help, or if anyone else wants to present at this tug in particular, email me at team.datafam@gmail.com. So again, thank you, Robbin, for your time. That was, I found it very useful. I think there's not much chatter in the chat tonight, but all the comments that were there were very complimentary, and it was just awesome to see how those calculations go into doing those sort of things in Tableau as well.
It's my pleasure. It was great fun.
Awesome, thank you. And now if anyone else wants to unmute and ask questions, now's the time. Everyone's going to sit there quietly.
I did get a comment about me talking at 2 times speed. That might have been right. But I hope you could at least hear what I was saying.
Well, there's always a recording. So, on parts of that, I want to go through and watch it as well, and just follow along, because obviously the recording, you can have it up on YouTube and pause it every 10 seconds while you're building it yourself, just to get to know that.
I was surprised I could keep it at 50 minutes. Like with this, I always cut content before, but this time I was on a flow, uninterrupted.
Yeah. That's good. No, work well. And as I said before, there's no time limit. So we've had presenters on that say they're going to take 40 and they take more than 70. I'd rather get the content. So I'm never going to chop because the presentation's good. If you need that long, take that long. That's easy. And if no one's going to say anything, that's the end of the meeting.
Thanks, guys. It was nice to listen in.
Okay.
And just understand the format that you guys are doing. It gives me a really good perspective of what our user group program is doing to help other people bring together the power of Tableau. So I'm going to drop. And if you need any questions, Chris, you know how to reach me.
Easy. Okay. Thank you, Melissa. Thank you for attending.
No problem. Bye.
See ya. I think that's about it. If no one else is going to say anything, that's the end of the meeting.
All good. Thank you very much again. I'll drop off as well. Have a great evening, everyone.
Perfect. No, thanks for that. It'll be online soon, so I'll send you the link.
Awesome. Thank you.
Okay. Thank you. Okay. See ya. Bye.